All right, so now that we know what a binomial experiment looks like, at least in theory, we are going to try to test our knowledge against some problems here. So, and I've written down here the 4 core things that we're going to be looking for when we look for a binomial experiment. Namely, do they have a fixed number of trials? Is there independence or not? Is there are there two mutually exclusive outcomes or not? And is the probability of success the same for each? So let's check it out. All right, so we begin with the top one. It's the percentage of people who have psychiatric disorders is 20%. 4 randomly selected adult Americans are examined for psychiatric disorders. All right, so is it a fixed number of times? Yes, right? N equals 4. That's the number of times. And that's your N, by the way. Independence. Well, yes. I mean, if I have a psychiatric disorder, that doesn't have any bearing on whether you have a psychiatric disorder, right? Mutually exclusive outcomes. Yes, right? Either you have or do not have a psychiatric disorder. Okay. Probability of success is the same. Yes. P. Oopsie. P. There we go. Equals 0.20. And therefore, by the way, 1 minus P equals 0.80. And while I'm on the subject just for a second, since N equals 4, that means X equals 0, 1, 2, 3, 4. Because if there's 4 people total, you could have anywhere from 0 to 4 people suffering from a psychiatric disorder. All right, what about a jar? It contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacing them. Okay, so is it a fixed number of times? Sure. N equals 3. Okay, and you could have X equals 0 red marbles, 1 red marble, 2 red marbles, 3 red marbles. Are they independents? No. And then we're done. It's because the selections are without replacement. If that's the case, then every time you select a marble, you're fundamentally changing what's left in the jar, and therefore the probabilities are changing all the time, and it's not independent. Done. So big fat no on that one. So maybe I should be clear. This one's a no. This one's a yes. Yes, it is a probability or binomial probability experiment. All right, bunny rabbits. 1/4 of a certain breed of bunny rabbit have long red hair. What is the probability that in a litter of bunnies, exactly 3 will have long hair? So here's the problem we have right here. It is not a fixed number of times because N is unknown. It's equal to the size of the litter, but we don't know how big the litter is. So done with that one right off the bat. No. All right, Shaquille O'Neal had a career average of 53% making free throws. Suppose he is going up to the free throw line. Oh my gosh, I can't say that right. Free throw line for 4 shots. Is it a fixed number of times? Sure. N equals 4, which by the way means X equals 0, 1, 2, 3, 4. Are they independent? Most likely not. Because psychology comes into play. In other words, it's not really 53% every single time he goes up there. It changes on his fitness. It changes based on whether he made the last shot. And, you know, if he doesn't make the shot, then maybe he's going to feel more depressed and not be able to make the next one and so on. Okay. Some economists and statisticians argue that with pro players like Shaquille O'Neal, that the independence thing it happens more readily for them because they do so many of these shots. But for your average players, of course, psychology really enters into it. But I would argue, I'm not a pro player, but I'm just thinking psychology has to be part of the game. Otherwise, everybody would be robots out there, right? So I'm going to argue that they're not independent. And since they're not independent because he would get affected by whether he makes it or not, then that's not binomial either. So on this page, the only one that was binomial was the first one. All right, I hope that helps you understand binomial. Next time, we'll start finding some probabilities with it.